Our brains are just wired to see patterns. It's what we do. We see connections everywhere. But what happens when those patterns we spot are actually misleading us? Today we're going to unmask one of the biggest and most important ideas in understanding data, the difference between correlation and causation.
So let's get into it, and welcome, by the way, to what I like to call the Tao Salon of statistics. Think of this as a quiet spot where we can just cut through all the data noise out there and find some real clarity. It's all about learning to see the world a little more sharply.
So here's the central puzzle for today. You see two things happening at the same time. When A goes up, B goes up. They move in perfect sync. But how do we really know if one is causing the other? Is the connection actually real? That's the mystery we're going to crack.
And that leads us right into our first big idea, this powerful and, let's be honest, often very misleading illusion of connection. This is exactly where our amazing pattern-seeking brains can kind of get us into a bit of trouble.
Okay, this next part, this is the golden rule. If you remember one thing today, make it this. Correlation does not imply causation. It's so important. See, correlation just means two things are moving in sync, that there's a relationship. But causation, that's the heavy hitter. That means one thing is directly making the other thing happen. And confusing the two, well, that's the classic trap.
To really wrap our heads around this, we have to look at some evidence. And believe me, this is where data starts to get wonderfully weird.
All right, check this out. On one hand, you have ice cream sales. On the other, shark attacks. And what's wild is, when ice cream sales shoot up, so do shark attacks. If you put this on a graph, the lines would look practically identical. So what are we supposed to think here? Does enjoying a scoop of vanilla bean somehow send out a secret signal to sharks? I mean, when you say it out loud, it sounds completely nuts, right?
Yeah, probably not. The fact that it sounds so absurd is a huge clue that something else must be at play. And this isn't just some one-off weird example either. Let me show you another one.
Okay, now how about this one? The data shows a really tight link between the number of people getting master's degrees and the total amount of money movies make at the box office. As one goes up, the other goes up. Statistically, it's another super strong correlation.
So, what's the story? Does finishing your thesis suddenly give you an uncontrollable urge to go see a blockbuster? Are universities secretly working with Hollywood? What's going on?
Again, it just doesn't feel right, does it? These examples are perfect because they scream at us that a pattern isn't always what it seems. So if A isn't causing B, then what is the real story here?
This is where we put on our detective hats. We need to investigate. If it's not a direct cause, then what is it? Well, it turns out there are usually three main culprits hiding in the data, three hidden explanations we can look for.
First up, we have suspect number one, the confounding variable. You might also hear this called a lurking variable. Think of it as a hidden third party, a secret puppeteer that's actually influencing both of the things you're looking at, which is what makes them appear connected.
And this is exactly what solves our earlier mysteries. For ice cream and sharks, the confounding variable is warm weather. When it's hot out, more people go swimming, and more people eat ice cream. The two aren't causing each other. And for the degrees in movies, the confounding variable is a growing population over time. More people in the world means, well, more people doing everything, including getting degrees and going to the movies.
Okay, our second explanation is what's known as a spurious correlation. And this one is when two things have absolutely no real connection at all, but just by pure random chance, their data happens to line up. It's literally just a coincidence.
The classic example of this is the decline in measles cases matching up with the decline in marriage rates in the US. I mean, come on, does one cause the other? Of course not. One trend is thanks to amazing advances in medicine, like vaccines. The other is about shifting social norms. There are two completely separate stories that just happen to unfold at the same time.
And that brings us to our third and final culprit, which honestly can be the trickiest to spot. It's called reverse causality. This is when there is a real cause and effect relationship, but you've got it completely backwards. You think A is causing B, when in reality B is causing A.
Now, you might be thinking these are just fun, quirky examples, but understanding this stuff is so critical in the real world, especially in business, in marketing, in any kind of research. Getting this wrong can lead to some really costly mistakes.
I love this real-world story from data analyst Gladson Sharma Mazinga. He saw that customers with high ratings also happen to be frequent visitors. The obvious conclusion, right? Happy customers come back more often. But when he really dug in, he realized the truth was the reverse. People who were already frequent visitors were simply more likely to leave a rating. The frequency was causing the high rating, not the other way around. Imagine basing your whole marketing strategy on the wrong assumption there.
So how do you avoid falling into this trap? Just use this simple data detectives method. Step 1. Spot the pattern. That's the easy part. Step 2. Immediately challenge the obvious link. Ask yourself, hold on, does A really cause B? And then step 3. Hunt for the hidden story. Go looking for our 3 culprits: a confounding variable, a pure coincidence, or reverse causality. The bottom line here is this: getting good at this isn't just some academic exercise. It's what stops you from pouring money into a marketing campaign that's targeting the wrong thing, or changing your whole business strategy based on a false premise. It's really about making smarter, truly data-informed decisions.
So let's wrap this all up by reviewing the powerful new tools that you now have in your critical thinking toolkit.
From this point on, whenever you see 2 things linked in the news or in a report, just run through these 3 questions. Number 1, is there a hidden factor, a confounding variable, that could be causing both? Number 2, could this just be a total fluke, a spurious correlation? And number 3, wait a minute, could I have the cause and effect completely backwards?
So I'm going to leave you with this final thought. The world is just drowning in data and headlines that are screaming about surprising new connections. But you now have the tools to look past the surface. So the next time you see one of those headlines, ask yourself, what hidden story am I going to look for?